Good morning all. It's a bank holiday weekend. That means it's a 3-day weekend. And the weather's not half bad. It's starting to warm up, so it's the perfect day for mowing the lawn. And I've no doubt that within a few hours there will be a cacophony of lawnmowers all buzzing away in the neighbouring gardens. But I've mowed my lawn already. I did it yesterday. And I did it with this lithium battery. So today I'm going to take it apart and have a look inside. So this is the 36 volt 2.6 amp hour lawnmower battery that came with the £149 Lidl lawnmower, actually Florabest brand. Let's take it apart. And I'd just like to say, while I'm undoing these 4 screws, a massive thanks to everyone who comments on the videos, not just the one I did yesterday on the lawnmower, but on all my videos generally, because the comments are where we all learn something. Hugely important. I learned something yesterday about this battery, well, more importantly about the cells within it, from everybody's comments. So a massive thanks to people who comment. Keep commenting, it's really, really important. Okay, there are the 4 screws out. Let's see if I can get the base off. I did do this yesterday, so I know it comes off. Alright, there we go. The most difficult bit is getting these release clips to come away. And we're in. Just before I lift this out and look at the cells, let's have a quick look at the electronics. Just an overview at this point. I'll go into more detail later. We've got some nice high current connection strips here, double strips. It says here P minus, B plus and P plus, charge minus and NTC. So this one's just used as a temperature sensor. 2 big MOSFETs here. You can see that the sources are in parallel, the drains are in parallel, the gates don't really matter. So these 2 are in parallel. These are almost certainly the load disconnect, which shuts off the motor when the cell voltage gets too low. A couple of controller chips here, and you can see fairly obviously there are 10 balanced charge circuits here with the 10 resistors. And 10 switching devices. They may be MOSFETs, they may even be bipolar transistors because the current flowing through these circuits isn't huge. Okay, let's lift this thing out and have a look at the cells. So this is a very snug fit, but it does fit really quite well. And here are the cells. Now, there are 7, 6 and 7, which is 20 cells, and you can I'm not sure how much of this side protection stuff I can pull away, but you can probably see that they're double spot welded and that we have pairs of cells in parallel. So this is a 10 cell, it's a 10S2P, 10 in series but 2 in parallel. So parallel pairs all the way through this thing. Right, let's get in close on the cells and see what they are. Right, the cells are lithium ion cell 18650P. Now here it says I. I'm not sure whether that's a C or a bracket. It doesn't quite look like a C because it descends just below the N, but NMR is really the first clue as to what these cells are. 18/6, and that probably says 65 or 650. These are 1300 milliamp hours. Now I said something yesterday about recycled cells and stuff like that, but in fact these cells are engineered to be low capacity, high current. I suppose in simple terms you can think of it as if you put less chemicals in the cell, you get less storage capacity, but more space for physically larger electrodes, that sort of thing. But low capacity, high current. Now 3.6 volts is interesting because, well, let's start with this NMR. The M could possibly mean manganese. I'm not 100% sure about that because these 3-letter codes can be manufacturer specific. They may not necessarily refer to the chemistry. Manganese is generally known to be 3.7 volts, whereas cobalt is 3.6. So the 3.6 here points to these possibly being cobalt. So there is a bit of a ambiguity here. I'm not entirely sure what they are. One thing that is interesting here is the manufacturing date, 1603, 2016, March. Well, today I think is the 1st of May. So the oldest these cells could possibly be is about 8 weeks old. They're very new. Now I've tried to find references to this NMR code, and I found ICR is lithium cobalt oxide, IMR lithium manganese oxide, so that's probably the closest to the NMR of the cells in this battery. IFR is iron phosphate, and INR lithium iron phosphate. Those two look the same. But Battery University has types of lithium ion. Lithium cobalt oxide they're showing as 3.6 volt nominal. Lithium manganese oxide they're showing as 3.7 volt or even 3.8 volts nominal. Then you've got lithium nickel manganese cobalt oxide and lithium iron phosphate, of course, which is totally different. Then there's lithium nickel cobalt aluminium oxide. So it all starts to get very complicated. Lithium titanate is very different. That has a 2.4 volt nominal cell voltage. So I can't decide whether these are manganese because of the M in the NMR code, or cobalt because of the 3.6 volt marking here. Any thoughts? Gratefully appreciated. What is certain is that these cells are engineered for high current and low capacity. 1300 milliamp is pretty low capacity compared to some of the top capacities like 3400 milliamp hours. Now this lawnmower ran for about 15 minutes, so it's discharging the cells at about 4C. Well, 4 times this number here is approximately 5 amps, and because we've got 2 cells in parallel, we can reckon that the lawnmower is probably drawing about 10 amps out of this pack. And it would appear to me that these connectors here are probably rated for about 10 amps. That's kind of what they look like. Right, let's have a look at some parts here. The 2 big MOSFETs which are in parallel are RU75230S. I'm pretty certain these are load disconnect, so the full motor current is going to be flowing through these. Let's take a look at the datasheet. These are RUI chips, RU75230S, N-channel MOSFET, 75 volts, 230 amps. Now, of course, there's no way you can get 230 amps through these small legs here, so that's a nominal value based on the on resistance, which is very low, 2.6 milliohms. Now you can just about make out the markings on one of these balanced charger controller chips, 8905AA0, possibly 1SN or JSN or even ISN, but I can't find any reference to those online. They're just going to be a balanced charger chip. There are a couple of low value resistors here. They've used 2 different values, presumably to make up a fairly accurate value. These are in the current path through to the main load controlling MOSFET. So this must be, I guess, overcurrent protection because they're measuring the current flowing through these main control MOSFETs. So would this thing cut out if it went over current? Yeah, possibly. There's a little module up at the end here, which is the 4 LED battery state of charge monitor. Now there's only 2 wires going to it, and I assume they're straight across the 36 volts. There is a 36V as part of this part number here, so this is probably just making an estimate of state of charge based on the voltage of the pack. So just a final look at the markings on this cell before I put this thing back together. 18650 NMR 18/6 something. Now I can't get to the end of what this says because although there is a screw here which looks like you could take the 2 shell halves apart, you can't because the tab metalwork is attached after the cell casing halves are put onto this thing. 3.6 volt, 1300 milliamp hours, 4.68 watt hours. Right, let's put this battery assembly back in its box. It is a fairly snug fit. Oh, I think that's it. As long as the LEDs line up with that thing, then I think I'm alright. In fact, the hardest part about putting this back together is getting these little springs on the springy release catches into these little dimples on the plastic moulding without it sort of leaping out and touching onto some battery terminals. So I'll just put that all back together, and then I'll take this thing outside and we can have a listen to the brushless motor. Now, some people said they wanted to hear the sound of the motor spinning up and spinning down, so I'll do that now. Not sure whether that's a direct drive or a belt drive. I can't see how it could be a belt drive because the motor looks to be directly above the circular cutting area, but I'm not 100% sure. And now I'll try and capture the sound of the motor straining a bit on this section of long grass here. Let's try that. Well, it didn't seem to be straining much at all there. I think possibly because that grass has had a chance to dry out a bit. Now, one thing I should say before I finish, and before everyone rushes out to buy a £150 Floribest lawnmower from Lidl, is that the battery is not covered by the guarantee. Now, whether that means it's not covered by the 3-year guarantee and or it's not covered by the 1-year statutory warranty, I don't know, but it says here this guarantee does not extend to cover products, parts that are subject to normal wear and tear and may therefore be considered as wearing parts, blade screw and battery, so not covered by the 3-year warranty. The question is, I suppose, is whether the cells in here, these 1300 milliamp hour cells, low capacity but high current, can weather the storm of a year or possibly even 3 years of mowing with a current draw of about 10 amps, draining the entire pack in about 15 minutes. How long is this pack going to last? Well, we'll find out. Cheerio. Good morning all. It's a bank holiday weekend. That means it's a 3-day weekend. And the weather's not half bad. It's starting to warm up, so it's the perfect day for mowing the lawn. And I've no doubt that within a few hours there will be a cacophony of lawnmowers all buzzing away in the neighbouring gardens. But I've mowed my lawn already. I did it yesterday. And I did it with this lithium battery. So today I'm going to take it apart and have a look inside. So this is the 36 volt 2.6 amp hour lawnmower battery that came with the £149 Lidl lawnmower, actually Floribest brand. Let's take it apart. And I'd just like to say, while I'm undoing these 4 screws, a massive thanks to everyone who comments on the videos, not just the one I did yesterday on the lawnmower, but on all my videos generally, because the comments are where we all learn something. Hugely important. I learned something yesterday about this battery. Well, more important